Alright, today's lesson is on finding rational zeros. Reminder, what is a zero? Well, a zero is simply a solution to the equation. So we'll write solution. The other thing is where the graph, if you were to graph it, crosses the x-axis, which is called the x-intercept. Another word that we use for a solution is root. And it's always when f of x equals 0. So this means if I was to substitute x into my equation, my output would be 0. Alright, so use synthetic division to determine if the following values are zeros. 1, 2, -1, and -2. I'm just going to choose one of these, and I'm just going to choose this 2 right here. Let's try it. So if 2 is the solution I'm trying to check, I'm going to put it in this little corner. So your solution goes in this little corner. And then I put the coefficients. Now, you learned the remainder theorem and you learned synthetic division recently. So I'm going to go through this a little quickly. What I'm looking for if 2 is the solution, that is if my remainder is 0. And so we're going to use the coefficients of these numbers. And notice we're missing a fifth, a cubed, and an x. So we got to keep that in mind. And you want to look at that right away. So the coefficient here is a 1. The coefficient here would be a 0 because I'm missing that term. Coefficient here is -2. Here I'm missing a cubed, so I put 0 for the coefficient. Then I have a -11 for the x squared. Then I would have an x term, so I have to put a 0. And then the 12 on the end. Then I just put a little line here. This number drops down, so it's a 1. And we always multiply from here to here. 2 times 1 is the 2. And then we add down. So 0 plus 2 is 2. And I kind of start over. 2 times this 2 is 4. -2 plus 4 is 2. 2 times this 2 is 4. 0 plus 4 is 4. 2 times the 4 is 8. -11 plus that 8 is -3. 2 times that -3 is -6. 0 plus a -6 is -6. 2 times the -6 is -12. When I add these two together, I get 0. Now, I don't really know what's going to happen before I start this problem. In this case, I ended up with a 0 here, which means this is my remainder. This number always, the last number here is the remainder. If it's 0, then your value is a solution. So x equals 2 is a solution of f of x. Alright, now I'm not going to test all the other 3 that are left. What could happen here is they could all be solutions, maybe none of the rest are, maybe 2 are, 2 aren't. You're going to have some homework similar to this where you test all 4. I'm going to save some time here and only test the 1. If this number on the end is not 0, then the number itself is not a solution. Alright, let's move down to our next problem. Alright, this says decide if the given x value is the 0 of the polynomial or not, and we skip right to x equals 1. The previous problem we could have worded this exactly the same. So they're same really questions, just worded a little differently. So we're going to put 1 in this little corner right here. And we're going to use synthetic division again to test to see if this is a solution. Now this one's kind of nice because I'm not missing any terms. Cubed, I got a squared, I got an x to the first, and an 18. So I'm going to put a 1 here, a -2 here. I've got -9, and I've got 18. Put the little line. We always drop down the first number, which is 1. And again, we multiply from here to here. 1 times 1 is 1. -2 plus 1 is -1. And we multiply 1 times -1, which is -1. Add the 2 here. -9 and -1 is -10. Multiply 1 times -10, and I get -10. And 18 plus -10 is 8. Now this is our remainder. Our remainder is not 0, and so x equals 1 is not a solution. Of f of x. Now I want to backtrack just for a second here, and another way to ask this question would be if x equals 1 is a solution, then x minus 1 would be a factor. So instead of saying is x equals 1 a solution, I could ask is x minus 1 a factor of f of x. I should put is in front. So this is another way to ask that. So notice, if it's a factor, it's x minus 1. If it's a solution, it's x equals 1. Zero product property backwards. Alright, so this is just, again, another way to ask the same question. Is x equals 1 a solution would be the same as asking, is x minus 1 a factor of f of x? And in this case, of course, x minus 1 would not be a factor because my remainder was not 0. And that's important because we're really going to use this to factor or find remaining solutions. Okay, next problem. Given one zero of a polynomial, find the remaining zeros. Alright, so I'm telling you right here that 4 is a solution, which means I kind of know where this is going. I know I should get a remainder of 0. Now, before we get started, we should see if we could factor this by grouping like we do normally with 4 terms, but we can't. If I tried it wouldn't work, and so this is why we do this method, to factor things we wouldn't normally be able to do. So I just need a lot of room, so I'm going to put the 4 way over here. And I'm going to write these coefficients like we normally do. So this is in this little corner with synthetic division. And I notice I've got a cubed, a squared, an x, and a number, so I don't need any placeholders or zeros. So I'll write the 2, and then the 3, and then the negative 39, and then the negative 20. Alright, so I'll write my line. I'm going to drop this 2 down. 4 times that 2 is 8. 3 plus that 8 is 11. 4 times 11 is 44. Negative 39 plus 44 is 5. And when I take 4 times 5, I get 20. Negative 20 plus that 20 is 0. And I knew I was going to get 0 in that spot for my remainder. Alright, so let's continue on. I'm going to use this to factor. So f of x equals, if 4 is a solution, we know that x minus 4 has to be a factor. And then the remainder of this polynomial here, which is the same as my original, comes from, this was a cube, so I know this goes down to a squared automatically by a power of 1 with these coefficients right in order. So I have 2x to the squared plus 11x plus 5. Now I want to keep going and try to solve this now. So I'm going to set it equal to 0 and try to factor this further. So we're going to use the guess and check methods where if 2x squared goes here, I know I have a 2x and an x. I want you guys to try to factor this 2x squared plus 11x plus 5. Find the numbers that go in these spots right here. Alright, I start it for you. I'm going to pause and I want you to... Alright, we should have had a plus 1 here and a plus 5 here. We didn't really have a lot of choices. 1 times 5 will give me this 5, and then when I multiply this 1x in the middle, and the ends, the 2x times the 5 is 10x. 10x plus that 1x is the 11x. Alright, now continue on using zero product property. It says I want to set each product equal to 0. So 0 equals x minus 4. I'll add 4 to both sides, and so x is 4. Then I'll set 2x plus 1 equal to 0. First thing is subtract the 1 and divide by the 2. So x will equal negative 1/2. I'll also set x plus 5 equal to 0 and subtract 5 from both sides. So x equals negative 5. Those three are all solutions to my equation. Alright, let's continue on with B. Same directions. I know that 6 over here is a solution. I want to find the remaining zeros. I've drawn a line over here so I can separate these. I'm going to actually need some extra room for this problem. And so I'm going to put my 6 here in my little corner. Notice I'm not missing any terms, so this is going to be a 5. And then negative 27. Then negative 17. and negative 6. Draw my little line down here. So drop down the 5. 6 times 5 is 30. I'm going to add here. Negative 27 plus 30 is 3. 6 times 3 is 18. Add negative 17, 18, I get 1. 6 times 1 is 6. Again, I know this is going to be a 0 here because I knew that 6 was a solution, or is a solution. So I'm going to factor like I did before. Since 6 is a solution, x minus 6 is a factor. And then this was a cubed, so this goes down to a quadratic, starting with a 5 in the first coefficient. 5x squared plus 3x plus 1. So I'm going to try to continue to factor this like I did in this problem, but I'll tell you right now, just to shorten things up, it will not factor. Sometimes it will and sometimes it won't. From here I could actually always use the quadratic formula if it's a quadratic in standard form. Alright, but it's quicker to factor like over here. This one will not. So I'm going to set x minus 6 equal to 0, add 6 to both sides, and that solves that part, even though I knew 6 was a solution already. Then I'm going to set 5x squared plus 3x plus 1 equals 0, and use the quadratic formula where a is 5, b is 3, and c is 1. And so I'll set up the quadratic formula over here. X is equal to the opposite of b, which is 3, plus or minus square root of b squared. So 3 squared minus 4 times a, which is 5, times the c, which is 1, all over 2 times the 5, which is a. And we'll simplify this. So x equals the opposite of 3 plus or minus square root of 9 minus 20 all over 10, which gives me x equals negative 3 plus or minus the square root of 9 minus 20 is negative 11 all over 10. And notice we're going to get imaginary solutions here. So x equals negative 3 plus or minus, the 11 won't break down, but the negative 1 puts an I right in front of the root. 11. Sorry about that. That's root 11 all over 10. And there are 2 more solutions there. All right. Now, in class, the next time we meet, we'll do example 4 with you, A and B. So don't try to do those on your own. We will do them with you. See you next time we meet.